Well, thanks for the introduction. Thanks for being interested in this subject. Even though it's a payment system from very far from this place, it's still a payment system, and we're talking about real money here. Okay, so, well, I'm doing all kinds of stuff, Linux kernel development, research in communication protocols, among them RFID, DEC, GSM systems, and so on. And I feel a little bit like 4 years ago when I last was involved with OpenPCD and open source RFID reader. That's sort of really the last point in time when I did RFID work. And in 2010, in August, I decided, well, let's have a look in how things have developed in the last 4 years. And I was really surprised to see what I see. So how did I end up with looking at this system in the first place? Well, starting from 2006, I was doing a lot of freelancing work in Taiwan. This resulted in a number of business trips to Taiwan, and specifically to the capital city, Taipei. In Taipei, as soon as you use public transport, you will see that almost nobody buys a single ride ticket, but everyone uses a small plastic card called the EasyCard. That's the English name, at least. If you literally translate the Chinese name, it's more the Easy Travel Card. But yeah, it's called EasyCard, and it's supposed to make public transportation easy. This was just after having worked a lot with OpenPCD and OpenPICC projects in the RFID area, but given that I was on business trips, I never really had enough time to look at the EasyCard system. Until in 2010, I thought, yeah, well, let's give it a try. So, what's this EasyCard? This is, as you can undoubtedly recognize immediately, a screenshot of Wikipedia on the subject of EasyCard. So you actually see it's a contactless smart card system, who operates it, and so on. You see an actual EasyCard on the bottom right-hand side. So it's just like any credit card-sized RFID card, just has a couple of strange, colorful spots on it. And as you can see already in this public website, even Wikipedia knows it is based on MIFARE, right? MIFARE being, well, I'll talk about that shortly. Okay, so it is a card that's used in Taiwan, mostly in the capital city of Taipei. It was originally deployed in 2001. That's what I found, well, according to Chinese sources. According to Wikipedia, it's June 2002, so there seems to be some off by one error. There are more than 18 million issued cards, so it's not a small niche market or something. It's 18 million cards. It's quite a substantial user base. And it was initially only a payment system for public transportation, mostly for the Taiwan Metropolitan Rapid Transport, called MRT, which is their subway or metro or whatever you want to call it. There are also public buses that use the same card for payment. It's very similar to other RFID contactless public transportation systems, like the Oyster card in London, or like any major city you travel to, except Berlin or except any German city, as far as I know. You have these RFID cards. Now, if you look at the EasyCard website, you find what it's being used for. So you have the Taipei Metro, you have bus services, also a rail line uses it for payment. All the government-run parking lots, some privately owned parking lots, roadside parking meters, a it's not a mono, it's cable car, the Maokong gondola, some riverboat services, bicycle rentals, and taxis. So that's mostly transportation that you can pay with it. The system, well, the cards, you can buy them at machines. It's like a ticket machine. Instead of getting a ticket, you get the EasyCard. It's located in every subway station, and I'm quite sure there are more, but at least in every subway station you find a couple of those machines. You pay 500 NT dollars, which is something like 12 euros, to give you some idea what it is. And of those 500 NT dollars, 400 NT dollars are the actual value that you can spend, and 100 NT dollars is a deposit on the actual card. The payment while obtaining the card is made in cash at that machine. Thus, since you pay with cash, there's no credit card or account number or anything linking a particular card to a particular individual. There's no connection, which, well, you could say for privacy reasons, that's a good thing. I agree it's good, but still, it's pseudonym. It's not anonymous, it's pseudonymous, because you just don't know the association, but you still have tracking profiles of each and every individual who's traveling. But then who cares about privacy in those countries anyway? Also another feature of the system is that you can get a full refund of the account balance at any given point in time, and even the deposit of the card itself by going to a counter and, returning the card and getting the money. Adding value to the card is made by the very same machines which are located in subway stations that sell the cards. So you put in your card, you put in some bills, some banknotes, and you get back your card that has a higher value charged onto the card. Which, all in all is, very interesting. But then if you look at what can you pay with that card, a public transport ride, which in Taipei costs you something like maybe 12 to 20 NT dollars, which is, something like, a couple of cents up to 50 cents, euro cents. That's not really some, very attractive target for anyone. It's, a couple of cents here and there. Yeah, sure, but it's, the fraud potential, the public transportation company may think it's big, but I think it's not really, when fraud potential is relatively limited. It's publicly known that the EasyCard uses this NXP MIFARE solution. MIFARE Classic specifically has been broken in various ways before, ranging from eavesdropping attacks, recovering the keys from recording conversations, to card-only attacks where all you need is the card to recover the keys. There are so many different attacks on MIFARE. I don't really want to repeat all of this here. However, one thing to remember, and I mean this talk is not about cryptographic attacks or anything like that. It's a a practical real-world attack using the tools and the cryptographic methods that have been developed before. One thing to remember is that the card itself is only one element in the security chain. So even even if you see, the system uses MIFARE, it must be broken. It's not that easy, right? The statement that they use a MIFARE card doesn't really mean the system is broken. They could have done it in a way that it's not so, not a big fraud potential. The big question it all comes down to is there online or offline verification, all right? If the value, the amount, the balance, your account balance, if that is stored only on the card, then of course manipulating the card is a very dangerous proposition because you can manipulate the value. However, if you actually store the value in the backend database and you only use the card as a means of authenticating the user to his account, but do all the transactions on the backend to the online to the database, then then there wouldn't be really that much problem. Because, even if there's a cached value on the card, if you manipulate it, the next time you make a transaction, it checks the central database, and there is the real value, the real balance of your card, and it is determined that there is something wrong, and it uses the value from the backend system. So I never, as I said, I've been in Taiwan since 2006. I never really looked at the system because I thought, first of all, it's only used in public transportation, and subway stations are, there are not that many. So it's very well imaginable that they do online verification because, what Taiwan, I don't know how many subway stations Taipei has, let's say it's 40 or 50 maybe. It's very easy to have leased lines there and access a central database. The other thing is, as I said, free rides, it's not a very, not a very big problem, I think. Now, unfortunately, you could say, in 2009, the government has created laws for, they call it stored value cards. I'm not quite sure if that's a term that's really used in English. I'm not a native speaker either. For a means of payment. Basically, they created laws so electronic cards where you can deposit some money can be used as legal payment system. Of course, the EasyCard Corporation being the only one actually having deployed such a system in Taipei, you can guess that it was specifically passed for enhancing the business of EasyCard. Now, so in early 2010, I think it was 1st April, the use of this EasyCard is extended beyond public transport. So now you can store up to 10,000 NT dollars, which is 240 euros. So not a significant amount of money, given the local purchasing power of that money. And the card is suddenly accepted by a lot of stores, mostly the big brands, the franchises, and so on. They all suddenly accept that card as means of payment. So suddenly the incentive is much higher. You can't only get free metro rides, but you can suddenly buy about anything that costs less than 240 euros in even the largest department stores that the town has to offer. If you again look at the website, these are the designated stores. You may not recognize many of them if you haven't been to Taiwan, but it's basically, most of the places you run into. 7-Eleven, Family Mart, OK Mart, and High Life are the 4 convenience store franchises that you find, every 100 of meters or even less, you will find one of them, and they sell about anything. So those are, tens of thousands of stores. Welcome is the largest supermarket chain in Taiwan and Hong Kong. And there is stuff like Watson's, which is a drugstore, Starbucks, everyone knows Starbucks, so, coffee, so on. I can go, Pizza Hut, Domino's Pizza, and so on. And also SOGO, which is a very large Japanese department store chain that has various department stores in Taipei City. You can also get sushi, and Cold Stone is ice cream, so basically you can get anything. Okay, now the card uses a MIFARE Classic system. By the way, it used to be called only MIFARE, and then after some advances in security research have been made, they have retroactively renamed it to MIFARE Classic. It's a 13.56 megahertz RFID system. It's magnetic coupling. It uses ISO 14443 1, 2, and 3, but it does not use ISO 14443-4, which means that up to the anti-collision level, it uses the same protocols that, for example, electronic travel you actually call them travel documents, electronic passports and so on use. However, the upper layer is not the same that is used with those passports. They provide something like 1 to 4 kilobits of storage, which are divided in sectors and blocks. And they use a proprietary 48-bit cipher called CRYPTO1. Proprietary and 48-bit should ring at least 2 alarm bells. It uses a proprietary 48-bit symmetric cipher, right? It's a 3rd alarm bell. Manufacturer and customers really believed in security by obscurity. That's something that I personally never understand. How could anyone who is in charge of IT security of any system that uses a MIFARE-based solution, right? Yes, it's proprietary and so on, but it was always publicly documented. It's proprietary 48-bit symmetric cipher. And if you are in charge of IT security of any organization and you are to deploy something that affects your business, be it an access control system where that card is the only factor in authentication, or being it an electronic payment system, I don't know how anyone responsible could use such a system. So nobody should have ever used it for any application requiring any sort of security. The weaknesses in the CRYPTO1 and the MIFARE system have first been published 3 years ago by Hendrik Plötz and Carsten Nuhl at this very same event 3 years ago, if some of you remember. Their initial presentation has triggered a lot of academic research in the Netherlands and other countries, various universities. And based on their initial weaknesses and all the security and cryptographers looking into it, a number of real-world attacks have been developed from various different ways. Now, if we want to analyze the EasyCard, well, there's a couple of things we need to do. First thing is we need to find out if it is really a MIFARE Classic card. I mean, it could be just that somebody heard it and put it in Wikipedia or something. And that can be very easily done by applying the compatible air interface. By the way, a 4 is missing. It's ISO 14443, not 1443. And do the anti-collision procedure and check the result values you get from there. That's very easy. You can do that using OpenPCD or any other RFID reader and so on. It's not, it's a straightforward thing. The next step, of course, is, you want to recover the keys. Each of the sectors on the card can have 2 different keys. That's key A and key B for 16 sectors, gives you 32 keys. many cards that you will find in the real world have one or more sectors that use the default manufacturer keys. So there's some keys that the manufacturers, when they build the silicon, there are some default keys for all the sectors. And in many applications that use MIFARE Classic systems, you don't need all of the sectors, right? If it's just a card that you use for a coffee shop or something, the coffee shop doesn't need to store 4 kilobits of data on the card. They just want to store your customer number or something. It's not 4 kilobits in size. So what do? They only use a single sector of the card, and all the other sectors remain at the same manufacturer default key. If that is the case, you can break the keys very easily. There is one particular attack where you authenticate to one sector using the known manufacturer key, and then you escalate from there by authenticating against a different sector. And that's a very, very quick attack. Has been publicized. There are open source tools for it. So the first try I made was, of course, to look at whether the EasyCard on any of the sectors uses the default key. Unfortunately, it does not. Well, fortunately for them, unfortunately for me. So there is a different type of attack. It's called the dark side attack. I'm not quite sure why the author called it that way. There's a paper by Nicolas Courtois, yeah, it's generally referred to as the dark side paper. That paper is public, and it describes how it works. And there's an open source implementation called MFC UK. You can probably understand why that is. And it's the MIFARE Classic Universal Toolkit, of course, as it's pretty obvious from that name. The hardware you need for doing that is basically, well, MFC UK is a program that will do the key recovery using libNFC. libNFC is lib near field communication. It's a library that can talk to a number of RFID readers from various different vendors that all use the same ASIC, the same actual chipset for the protocol. The cheapest reader you can find new costs you about 30 euros. So you need an NFC-supported RFID reader, 30 euros, install libNFC, install MFC UK, and then you start the program, and you can start to recover the keys. It took about 3 hours to recover all the 32 keys. That's sort of, the massive amount of time it needs. And the attack time could be much shorter if you were using more expensive hardware on the reader side. This attack, the attack is based on the fact that the random numbers generated by the card are not really random. They're deterministic, and they only determined by the amount of time passed from powering up the card until you send the command. So by always powering it up and sending the same command at the same point in time, you can know which random number the card will have, and it's always going to be the same random number. So in fact, it is not a random number at that point. And doing this over, USB attached, all in software on the PC over USB attached peripheral, the timing you can do is not, timing accuracy and the latency over USB from software through the operating system onto the reader is very, suboptimal, so you cannot do as many cycles as you could do with something like the Proxmark, which is a specific, more research-oriented RFID reader, where inside the FPGA and the microcontroller there, you can implement all this, and it has been implemented in the firmware, and you can do many more cycles. So I haven't tried it, but you can get the attack time. If I would guess, I would say, you should be able to get it down to half an hour or even less. And that means you put the card, any random card, you put it there, and it will do its job, and afterwards you have all the keys for all the sectors. Now, next thing is we have recovered the keys. Obviously, we want to read what's in the card. Once the keys are known, the full data content of the card can be dumped. We can just read all those 1024, 4096, whatever amount of bits it is. There's a software program called MF Classic program, which is part of the libNFC, where you tell them these are the keys, now give me a complete dump of the card. Again, the reader you use is the same reader, and after you do that, you get something that looks like, let me just open just a second. I'm going to increase the font size, don't worry. Get something that looks like, this is still not. All right, this is the hex dump of the card content. So it looks something like this. You get lots of hex numbers. You don't really know what they mean because all you get is a raw dump of the card, of course. So we can see, there's, some blocks that are completely zeroed out. Here again, we have lots of zeroed out blocks here is an entire sector. A sector is always 4 blocks, is also completely zeroed out. And we find more zeroed out sectors if you go towards the end of the card. It's always only 0. Okay, so we see some hex numbers here after we have read the card. Sorry for that. Too many desktops. Virtual ones, of course. Where did it go? Oh, I think, now I know what happened. Stupid me. There we go. Sorry for that. Around here. Yeah. Okay, so we use that, we read out the card. Now we need to understand how is the data organized on the card, right? So the logical approach to this is you do individual transactions, like you go into the subway, you read it before, you read it after, and then you compare what has changed in the data. And you do that again, you leave the subway station and you look what has changed again. Then you make a purchase, you recharge the card, you go into a bus, you rent a bicycle and so on. You do all these things and all the time you do captures, you reread the card again and see what's happening. In the subway station, that's, there's always video surveillance, so it might be a bit suspicious if you walk through the toll gate and you unpack your laptop and you have your reader and stuff. It might be a bit suspicious, especially considering, well, there's both video surveillance and there's always a guard at every station. There's no unmanned stations. So, but the other thing is that many subway stations, inside, after you've passed the toll gate, there's a public bathroom. So you can go in there, you plug in your laptop and your MIFARE reader, and then you can read the card again. Very convenient. No video surveillance there, not that I can tell. You look at this and you repeat it with all kinds of transactions. And what you end up with is, well, we can do something like, this is actually post-entry. So after entering the subway station, and I can now do something like diff the hex dumps of, I went into a station, made a dump, and then I left the station again and made a dump again. And then you look at the diff, and you see something like this, a lot of stuff is the same, but this has changed here. And you see this, 0x190, which if you convert it is something like, is 400 NT dollar, which happens to be the initial value after you've purchased the card. Right, 400 is the value. I said you pay 500 NT dollars, you get 400 credit, and so on. And then you see it gets replaced by 184, which means entering and leaving the MRT station has just cost you 12 NT dollars, right? Because now it's 388. So you have already found, by only looking at the first diff that shows up in the hex dump, you already see that this is very likely to be the amount that has been changed. And you see it has been changed here, right? This was 190, it has been changed to 184, has been changed over here, and you see some strange stuff over here, which happens to be the inverted value. So if you do something like, anyway, it's, it's FFFF minus the 100, minus the respective amount. So it's just a bit inverted storage. You see some other changes down here. So 001 has been changed to 002. 5 has changed to 1. It's not really clear what that is. A line with zeros has been replaced with a lot of other stuff. And there are more changes further down the road, which are not really clear at this point. But this is just to illustrate the actual steps that I did. Okay, now doing this with lots of transactions, you actually get an idea. Things change here, things change there. Then you enter the same MRT station using the same toll gate, and you see, some numbers are the same. So this must be the specific reader identifier or the station code that represents that particular MRT station, and you start to get a feeling of what happens. And it turns out there's a number of different things that you can find. Sector 2 is what we've just looked at in the hex dump. It's the balance. So this strange storage format of having twice the same value plus once the inverted value actually is what's called a MIFARE value block. This is a feature of the MIFARE card itself where it is intended, you have this block, it represents the value, in this case 400 NT dollars, and you have two different keys. One key can always only decrement the counter, and the other key you can write it. Now, given the fact that the keys are very easy to recover, of course, it misses the point. But at least until people have figured out how to recover the keys and do the cryptographic attacks, this was how the system was being designed. And the inverted storage is so you cannot flip single bits and make it work. So you have the backup copies and the inverted one, which means if you use like ultraviolet, right, or something on the EEPROM or flash storage, then you can only switch the bits in one direction but not the other. So by storing it, the value and the complement value, if you use light or anything like that, or to flip bits in the hardware, you would not be able to have a consistent reading again after you did that. So that was the idea of this system. Yeah, the value, as I said, 1-to-1 represents the account balance of the card in NT dollars. It's not really anything else about that. There come some other sectors which I have discovered to be the transaction log. It contains log information, the number of the last couple of operations that this card has been done. Stuff like a transaction identifier, the cost, like the amount of money that was involved, the remaining balance, at which particular MRT station it happened. You know, the RFID reader ID, was it entering the station, leaving the station, connecting is again a different operation, or purchasing something in cash, or actually recharging the card using a recharge machine. There's a timestamp associated, which conveniently is a 32-bit Unix time format in seconds since the epoch. However, it refers to Chinese Standard Time, not to UTC. So yeah, otherwise, it's the same. I was a bit surprised to see it like this because in Taiwan, the calendar starts in 1911, right? So right now we have the year 99, but they still use Unix timestamps here. So probably not enough political influence on the manufacturer. The MRT station code, how do we decode it? I mean, for adding money to it is not really important, but I wanted to understand what's going on. So it's the MRT station code. So you see, if you go to one station, you have 10. You go another station, you have 12. Now, you could go to each and all of the stations, and then you create your mapping. This is the station name in English, in Chinese, and that's the hexadecimal number that represents it on the card. Would be very tiresome. What was actually much easier is to go to the homepage, which has a nice map of the MRT system, and you put your mouse onto one of these station names, and in the URL line, the last 3 digits is the station code. In decimal, though, you still need to convert it to hex. Okay. Now, there's another interesting block or sector, it's sector 7, that contains the last MRT entry or exit record, which is, it contains the MRT station code and a timestamp. And it's used to compute the sort of, how can I say, it's not distance, it's difference, or, well, anyway. So when you switch from subway to a bus or switch between subway lines, then there is a discount. It's not as expensive as doing a bus ride and an MRT ride. And using the information in there, they discover, what kind of means of transport have you used last and when was that? Are you eligible for the discount? There is a maximum daily spending. You cannot spend more than 3,000 NT dollars per day with the single card. You can charge up to 10,000 on the card, but the daily limit is 3,000. And in sector 15, block 2 at offset 3E0, you have a record that contains the amount of money you have spent on a given day of the month. So it contains the day of the month. So let's say today is whatever, 29th. So it would mean 29, and you've spent whatever, 1,000 NT dollars so far on that day. And this is checked in all the transactions. And if that value reaches 3,000, the card is refused from any further transaction as long as the day of the month is the same. Using the scheme, as far as I understand it, if you were to wait exactly until the same day of the month happens next month, you would not be able to use the card. But I'm not entirely sure. Maybe there's something in the data format that I didn't understand, and I wasn't there for a month at that trip to actually validate that. Now, tampering with the card. Well, after we have recovered the keys and we understand the data format, tampering with the card, of course, is easy. We can do purchases on the tempered card to validate whether it really is an online or offline system, and possible manipulations are pretty obvious. We can decrease the value on the card, thus lose money. We can increase the amount of value on the card, gain money, and we can also bypass the daily spending limit by just resetting it so you can spend even more in a single day. We could also do things like recharge it to even more money than you can charge it to, but I think that would start to become suspicious. Or people would think you're like a government official, I don't know. Somebody who has extra privileges, no idea. Or whether the readers would actually accept it. So the first thing to do, of course, is decrease the value of the card. You make a purchase in a store, you find the transaction log entry, you retroactively increase the cost of the purchase. So you've purchased something for 100 NT dollar, you increase it to 400, and then you decrement the value block storing the account balance, the card balance, by the same amount, and suddenly you have a card that's completely consistent with itself, but has less money. You also have to order the amount you've spent on that day, because suddenly you've spent more money on that day, to make sure everything again is in a consistent state. Now, let me just show you, I'm going to introduce that tool in a second. So I've written a program called EasyTool, and I can do something like, well, post MRT entry. So what we get here is the unique identifier of the card. The day of manufacture of the card, we get the current account balance, 400 NT dollars. This was when I started. No purchases today. I have entered the Liujiangli station, and I haven't left any station yet, because that was after entering the station with a newly purchased card. And you see the transaction log has, again, 2 copies of the same record. This is the date, timestamp, and so on, and the amount of dollar that's still remaining on the card. Now, after leaving, there was a different timestamp, of course. After leaving that very same station, the card looks a little bit different. Well, we only have 388 NT dollars left. We have left the same station at exactly 4 minutes after entering it. Well, you could have left something at home, and you need to, go back home and grab your laptop or something and go back. Transaction log. Also, if you're a foreigner, tourist, of course you get lost. You leave the same station again. You see the transaction ID gives you 1 is the first transaction and 2 is the second transaction. You will again see everything is copied twice. I didn't order it by date or transaction ID or something. It just dumps it in the order that's written on the card. So we have leave MRT, enter MRT, and so on. It has cost me 12 NT dollars, and 388 is remaining. And if I do the same with further, where is it? I actually went to Starbucks and had a coffee. I'm not a coffee drinker, so, well, anyway. So, we have a shop purchase of 95 NT dollar, which is, I think, as much as a coffee frappuccino tall size is in Starbucks, Taiwan. And we have 293 NT dollars left on the card. So the format is very well understood at this point. We can decode everything. We can read the transaction log and so on. Now, manipulating, as I said, decreasing the value is the first attempt we can do. The other thing, of course, is, we can do it, and it has been done. Card behaved like expected. So it had less value remaining, not only in EasyTool, but also when you go to the shop. It was still possible to use it anywhere, in shops and in public transportation. The artificially removed money could not be spent. So when the card reached 0, you could not spend any more money, meaning that the value stored on the card is really the value that the system respects, not some value in the backend. And the card could still be recharged at recharge machines. So even at the recharge machines, they didn't know what's the real value of the card, but they just read what's on the card and incremented it and write it back to the card. I would have expected at least a recharge machine to have some online connection and a shadow account in a database where you then can correct the offset, but that was not the case. By the way, this was my second attempt. The first attempt, the card actually failed. I couldn't buy what I wanted to buy. So I made some inconsistency in the data structure. But yeah, it was second attempt was then working. Now, the next thing, of course, you can do is increase the value on the card, right? It's not really that different, right? You find a transaction log and you decrease the cost of the previous purchase. So let's say you buy something for $300 NT and you suddenly retroactively make it cheaper to $100 NT, which gives you an extra 300. You increment the value block accordingly. You manipulate the amount spent per day in sector 15 to reflect the reduced amount, and suddenly you have more money on the card. It has been done, and the card behaved like expected. It had more value remaining. It was possible to use it in stores and public transport, and you could spend all the money to the last NT dollar, even the money that you didn't really have. Just the card said you have it. So once again, proof that it's an offline system. There's no online database check. And the card could again still be recharged at recharge machines without losing the artificially incremented added amount of money. So just as a note, the money that was artificially added was immediately really added to the card later and then manipulated back. So, right, there's no fraud involved in this. So what happened is the card didn't have money, it was artificially recharged, something has been bought, just to prove the point. Then the card was actually recharged using the amount of money that was artificially added previously, and then it was manipulated to reduce that amount of money. So in the end, the balance was the same, and all the money that has been spent has actually been spent in cash. So there's no fraud involved in this. Okay, now, then there's this program, EasyTool, as I already showed. It understands the format. It also has code for adding and like incrementing, decrementing the amount. It has not been released to anyone. And I'm thinking of releasing a read-only version where you can just, I mean, it doesn't crack any keys, it doesn't recover keys, it doesn't do anything cryptographically. Assuming you have the matching keys to a card, with the version I intend to release, you can read the stuff that I have been reading, but there's the manipulation code I do not intend to release publicly. So let me just go through some more examples. So if we go further in the history of this, what happened? So I went to another store and bought something, I think this is not a card that had been tampered with. Just to show you a card that has some more transactions, it just looked like this. So you see some different station names, some different values, some different amounts, different shop purchases. But I can show you the actual yeah, so this is a card that I had been used. So originally it was charged with 1,000 NT dollars. It had a value of 237 NT, and I just bought something. The last transaction identifier is C3 here. This is the last transaction. I bought something for 75 NT dollars. And I manipulated the card to increase the cost of the C3 transaction to $275, leaving only 37 NT dollars remaining, right? This is the decrease part. So I increased the cost of the last purchase, and I decreased the total amount. And then, if we continue the log, there was some stuff, that it didn't work, but then, this is after spending some additional, in a C4 transaction, spending some additional 20 NT dollars in bottled green tea at a convenience store. So from 37 NT dollars, we get reduced to 17 NT dollars. So this was the shop purchase. And after we look at the next transaction, we see stuff like, I'm trying to find the increased transaction here. Not quite sure whether it's in this log file, but it's pretty much the same thing. Yeah, this I think is a modification of 275. I have to check. Maybe it's a different card where I actually added some value, but I think you get the point. You get the point of this entire exercise. So, using a MIFARE Classic or any RFID system based on proprietary security, that's based on security by obscurity, I think it's extremely irresponsible. And using a MIFARE Classic-based public transport system, which may provide sufficient level of security for public transportation, using that in the year 2010 as a payment system is, I think, ignorant, clueless, and a sign of gross negligence by whoever is in charge of this. I think government regulators should mandate the use of independently audited and reviewed security technology. Security by obscurity is not an answer to any problem. Well, my thanks slide to the various people who have made this possible. As I said, I didn't do anything in this case, but actually look at text dumps and find out what it was. It actually reminded me a lot to something like, 16, 18, 20 years ago when I was modifying saved games on the PC or the C64, right? It's not really that different. You go into the game, you do something, you look at the hex dump and you see where is the value for the amount of credits I have or for the amount of whatever ammunition or God knows what it is. It's not really any different in this case. Adding the sort of 3-hour key cracking time for that. Okay, well, thank you for your attention. Happy to take questions.
Well, Harald, you're very ahead of time, so we've got lots of time for questions. Sorry?
EasyCard Corporation knows about these problems. In fact, years before they went live with the payment system, I mean, it was still used for public transportation only. Researchers from various Taiwanese universities have tried whatever they could, writing letters to the government and to the company and so on, warning them of doing this, but they still did it. And there's a group of researchers at National Taiwan University which have done similar modifications than I did. I only spoke about them after I did it. And they are using different sort of less effective attacks. So they have a USRP in a backpack and, it's sort of much more cumbersome. They don't do card-only attacks. They actually have to sniff the communication between the card and the reader in order to get the keys. So different attack vector, but they have done the same thing. They have added value to the card. And they have actually done it on their student ID cards, which also have EasyCard functionality, which are clearly tied to themselves. And they have done this a couple of, must be about a year ago now, and they've never been contacted, and there's never any inconsistency has showed up with that particular student or that card or something. Nothing happened. So they could very clearly know, and as I said, they've been warned by the local academia very, very strongly, and they still decided to deploy the system, which, I don't know how this comes, but it's not my business either.
Okay, if you've got questions, can you put your hand up, please, and we'll get a mic to you. Can I get one of the audio angels to hand up? He's gone, hasn't he? Oh, no, there you go. Okay, yep, you first.
Hi, I just wonder, other than RFID card you've played in Taiwan, have you ever come across a card RFID system in mainland of China, say Shanghai or Beijing?
I've been to Shanghai and other places in mainland China. I think I actually have some of these cards, but I never really had time to look at it. As I said, I also have cards from Rio de Janeiro and Sao Paulo and other places wherever I go and use public transportation. But as I said, I never really had the intention or the time to look deeper into this. In Taiwan, this was just as I happened to be there that often, and all this work was done in 2 days, by the way. It was very, very quick. And very, very simple. But then I had a lot of existing experience with RFID systems. But still, it's really not a very, very difficult thing. I have no idea how other transportation systems work or what they use. I know in Japan they use a system called Felica, which is based on triple DES as far as I know. So the encryption is much stronger than MIFARE Classic, but I don't know what's used in Shanghai or other Chinese cities, sorry.
Yeah, because recently I just got this RFID card from Shanghai. The manufacturer claimed this is going to be their solution to replace the MIFARE card, and they are using their own proprietary algorithm to protect. So I think if you got time, maybe this can be one of your next projects, or anyone here.
Yeah. I personally have to say I'm too busy. I have too many projects going on. This was just 2 days in Taiwan just for fun. Now just one comment, you said, somebody's advertising, we have our own proprietary crypto to replace the other crappy proprietary crypto. I mean, they've said enough. I mean, it's sufficient for me to say, well, go away. Why don't you just use AES or DES or, something that's, generally well audited and generally well understood and where people think, there's a sufficient level of security involved. Proprietary encryption, I don't think it's going to work. Yeah, more questions?
Okay, fellow in the beard.
Okay, I think this fellow from China wants to save money on public transport. But I think in Germany there's also a card system, there's a standard from the VDV, Verein oder Verband Deutscher Verkehrsverbünde oder Verkehrsunternehmen, die, okay, in English, okay, they standardize all this stuff with stamping machines or the displays in the bus that says next station so and so. There's all this stuff is standardized, and also they have a smart card based system. But I think it's deployed in Hanover or something. It should be possible to make some further investigations if this is a good system or not, because I think it's some years old and so maybe has some flaws.
Yeah?
Yeah, that might very well be the case. As I said, I've sort of left the RFID world in 2006. It was just, I made one attempt and I was very lucky to find such an extremely, welcoming system. Sorry, an easy system. But yeah, I have no idea about Hanover. But of course, I mean, as I said, just go ahead. RFID readers are not expensive. All the documentation is out there, the protocol stacks, the implementations of the various MIFARE Classic attacks. Just check for yourself. It's no magic involved.
Okay, other questions? Put your hand in the air, please. Okay, so that fellow there, and then you in the shirt that I can't read.
The MIFARE break was hardly kept hush-hush over the past couple of years, particularly here at CCC. So I imagine the guys involved know these cards aren't too secure, yet they're pushing ahead anyway. Do you have any insight as to how much it would cost them to roll out something half decent?
The typical claim that the companies, the proponents of these systems make is that it's so horribly expensive to do. But then, I mean, okay, you have to go back one step. So what is the cost of deploying an alternative system? Last time I checked, and this was already in 2006, a MIFARE DES-FIRE card providing, triple DES encryption, even at that time, was less than $1 more expensive than the MIFARE Classic card. So the cost on the card side is that, yeah, you have to spend less than $1 more on each of the cards, which I think, given that you charge for the cards anyway as a deposit or something, shouldn't be a problem. The other part is that, of course, in the readers, you then need to implement triple DES have to have that in hardware or in software or on your microcontroller or something. But then again, we have the problem. I think it's actually the same problem we see in GSM-based stations, that people design, develop, sell, and buy such systems without previously thinking of in-the-field software upgrades and of having sufficient resources left over, as in flash and RAM and CPU processing power, to upgrade systems after they have been deployed. And that sort of is a claim that has been made by numerous companies, and I also think EasyCard has mentioned this against some of the some of the academic guys in Taiwan, that they just cannot implement triple DES in all their readers because they don't have the available flash or whatever program memory in those readers to actually put all the code in there. But yeah, then I think the initial investment is already broken because, buying hardware that's supposed to be there for decades without thinking of future-proof and upgradability is, again, I would say, of a security-related technology, is negligent. I'm sorry, it's sort of off-topic, but I know more about the GSM side of things, and there you can think that I think the GSMA has, in a GSMA statement, in 2009, they have the operators have started to think whether they should mandate in the future that cryptographic algorithms should be a software-only upgrade in their equipment, right? So 19 years or whatever after GSM has first been deployed, they start to think whether in the future maybe it's a good idea to keep algorithms as a software upgrade without having to replace the hardware. And that's sort of some idea of how the hardware industry, I don't know where they live. They live on the Mars or something.
Okay, where are we? This gentleman here, and then we'll take a question from IRC.
Okay, it's not just a question, but an experience I had myself. I'm from a university, and we have a payment system which is based on MIFARE. And I was just doing some research, in fact, the exact same thing as you did. And we do pay by MIFARE, and it's as insecure as this thing from Taiwan. So, and I know that other universities in Germany do have the same technique as we have. So it's common also in Germany.
Yeah, I'm not doubting that it is common here. Just not sure whether, for example, there are 18 million students having such cards in Germany. I would be surprised. So the deployment size of this system in Taiwan is definitely quite large. Yeah, but once again, even to those universities, I mean, it comes back to the actual cost of the equipment is not too much higher if you want to have something that offers a higher level of security. One thing I once heard from NXP was that they've never considered the MIFARE Classic as a security product internally. It was, they never thought of it as a security product. They have their secure smart cards like Smart MX and the Desfire and so on, and the MIFARE was never intended as a secure product in the first place. And but then you have companies that always try to save the last couple of cents without thinking of security, and that's what we see all over the industry. And then you end up with problems. And of course, fixing the problem now after having deployed 18 million cards and God knows how many tens of thousands of readers is going to be a very expensive proposition. Having it fixed from the first time would probably have been much less expensive. But well.
And now we'll take a question from IRC.
Yeah, the interwebs were discussing that in Amsterdam they introduced MIFARE for public transport just this year, just as a side remark. And they were also discussing how you could make such a system more secure. So could you think of any way of having a payment system using MIFARE get more secure? So they suggested like a server-side based system or online system.
Yeah, that's what I mentioned initially, right? If you have an online system, which many people again believe is too expensive, but if you have an online system, then of course nobody can artificially add money. All the threat you have remaining then is a cloning threat or something like that, where you can just clone somebody else's card and then spend his money. Which is still remaining at that point. And I think, what are we talking about? About less than $1 US for each card. Come on. I mean, why is anyone arguing about that amount of money? I don't understand why there's such a big problem to buy a more secure card. Yeah, but go and ask the users, go and ask the users. If you go to a user and say, do you want to pay $1 more, but to have a card that nobody can clone and can spend your money, then everyone would say, of course I pay $1 more. There are lots of people who spend money every month on having their ISP run a firewall for them, right? If people are willing to pay money for it. So you just say, yeah, you want a more safer card, pay $1 more. Why not?
Okay, this gentleman here. And do we have any other questions? If you've got a question, put your hand up, please. Any others? Oh, one there. Any others? Oh, and that gentleman over there in the back. Okay, cool. Take it away.
What is the approximate price for a card for companies like MRT for a single card or for 1,000 cards?
I have no clue, to be honest. I mean, as I said, last time I was researching anything about pricing in RFID cards was in 2006, and only the quantities like 1,000 units, right? And that's the quantities we bought for our open PCD cards. And there I think it was something like 40 cents for a MIFARE Classic and $1.20 or something for a Desfire. But this is, 4 years ago. The prices may have changed quite a bit by now. I have, and also in larger volume. Yeah.
Okay, and we've got 5 minutes, so that's probably 1 or 2 more questions. So, this gentleman, who wants to ask? It was you.
Have you tried whether they do an online check when you go for a refund?
I've never gone for a refund, no. To be honest, I only read about it. I wouldn't even know where to go. I would have to check where to go to get a refund, no. No.
I don't think that's a very good idea. Let's not do that. A Taiwanese prison's not cool. Okay, and we have time for one more, and then Harald will, I don't know, where you're planning on going after this.
I have just a comment. So in universities where you have these things to buy your Mensa food or stuff, there are also some university where you can use study fees with this card. And so if you have problems with your finance and you think that the study fees are too much, maybe you can do something against it.
So there's one chap there, and then we'll call it, because you've got a couple of minutes.
Yeah, maybe in order to raise awareness in the minds of the people responsible for such systems, maybe it would be an option to go the fire sheep way and create a program that is so trivial to use that it could be used really by a lot of people easily. For somebody who really cares about the deployment of such weak systems, maybe that's the only way to go.
A trivial MIFARE breaking toolkit.
Well, I think it's already fairly easy to do. I think the attacks have been publicized very well and very widely, especially in the Netherlands and in the UK. And just one more statement. I just remembered that I had a conversation with a large telecommunications operator in Europe recently, and they also use one of the, not MIFARE, but one of the competing but equally bad security-wise systems. And they said they are desperately looking for a supplier. I mean, this is a large telecommunications company. We're talking about, hundreds or thousands of locations where these readers and door access control systems and so on are deployed. It's for access control to all of their facilities. And they said they have not been able to find any single supplier that would use a RFID card with decent level of security in their system. They could not find it on the market. Right. So there's a clear failure of the market to provide adequate level of security. They would even want to buy it, but they cannot find a supplier for it. Right. The cards are there, the customers are there, but somehow the access control industry is, sleeping.
I smell a business opportunity for someone enterprising in the audience.